And then suppose we have this matrix is this, and this matrix can be calculated like just m transpose m 1 over m transpose 1 transpose m. So this one can be changed to this. Then let's check the one by one. What is m transpose m? What is 1 transpose m? 1 transpose m can be calculated like this. 1 transpose is 1 by n matrix, and m is n by 3 matrix. Then in this formula we can calculate like this row vector, this column vector here, this row vector, this column vector here, this row vector, this column vector here. So it is 1 by 3 matrix, 1 transpose m. Then m transpose m is equal, it can be calculated like this. Then where is it? M is this matrix, so it has a y vector, it has x1 vector, it has x2 vector. Then m transpose m can be calculated like this. Just matrix multiplication. This one, here, this one, here, this one, here, yeah, and so on. Then 1 transpose m transpose 1 transpose m means that this one. It is 3 by 1 vector, 3 by 1 matrix multiplying 1 by 3 matrix. So it will be 3 by 3 matrix. Then 1 transpose y means that 1 transpose y means that n times y. Can you agree this one? Okay. 1 transpose y. 1 y1 yn means that sigma yi means that n times y bar. Can you agree? Okay. Then this one is n y bar. This one is n x1 bar. This one is n x2 bar. So we can calculate this 1 transpose m transpose multiply 1 transpose m is equal to like this. So where SAB is equal to like this. This one SXY is equal to sigma xi minus x bar yi minus y bar. So here m transpose m minus this term means that S y transpose y minus n square y bar square means that S y. And then second element, y transpose x1 minus n square x1 bar y bar means that S x1 y. So all of these elements can be expressed like this. Can you follow this one? Okay. Then let's calculate the beta hat. Beta hat is equal to x prime transpose x prime inverse x prime transpose y. And here x prime transpose x prime is equal to can be calculated like this. Then it is Then this one and this one will be n. This one and this one will be 0 because covariance of 1 and x1 is equal to 0 here. Summation of xi minus xr is equal to 0. So this term and this term is equal to 0. And then this term can be calculated like this one and this one. So we can get the x1 and repeat this one. Then then we can get this matrix. N is equal to 15 and another things can get from this information. Sx1 x1 is equal to 10, Sx1, x2 is equal to 0. So we can get the x prime transpose x prime is equal to this diagonal matrix. And then x prime transpose y is can be calculated like this: one vector and y vector, and this vector and y vector, Sx1y, and this vector and this vector, or Sx2y. Then we can use above information. Sigma yi is equal to 45 here, and Sx1y is here, 30, and Sx2y is equal to minus 30 here. And diagonal matrix, inverse of diagonal matrix is can be calculated like this. So we can get the beta hat is equal to x prime transpose x prime inverse multiply x prime transpose y. So 45 first column vector, 30 second column vector, minus 30 third column vector. Then we can get the 3, 3, minus 2. It has very long process. Is it okay? Okay, last one. Last one. Just suppose the slightly different model xi1, c1 xi1, xi2, c2 xi2. It means that scaling by multiply c1 to x1 and xi2 from xi2 to c2 xi2 is that multiply c2, and xip cp xip is that multiply cp. So this model can be expressed by using this x prime that scaled by matrix C. So let x prime is equal to xc. C is a scaling matrix. C1 will be scaled x1 column vector, and C2 will be scaled x2 column vector. CP will be scaled xp column vector. Then x prime will be these x prime will be this matrix. So beta, we can calculate calculate beta hat is equal to x transpose x inverse x transpose y, and alpha hat is equal to x prime transpose x prime inverse x prime transpose y. So alpha hat can be calculated like this. So x prime is equal to xc. Then plug it, just plug it here. Then x prime transpose x prime will be c transpose x c, and by using this inverse term, we can rewrite like this. Then plug cancel down c transpose inverse and c transpose. Then alpha hat is equal to c inverse and x transpose x inverse x transpose y. And this term is beta hat. So alpha hat is equal to c inverse multiplying beta hat. And c inverse is inverse matrix of diagonal matrix. So c inverse we can get the c inverse like this one. So alpha hat is equal to this. Alpha hat can calculate like this. So alpha 1 hat is equal to 1 over c1 beta 1 hat, and alpha 2 hat is equal to 1 over c2 beta 2 hat. Alpha p hat is equal to 1 over cp multiplied beta p hat. So alpha j hat is equal to 1 over cj beta j hat. From j is 1 to p. Also, we can get the intuition in this problem. Slope of the line can be defined as delta y over delta x. Then these points have variation to delta x, and variation of y is delta y. Then let's plug in xi is equal to 1 over 2 xi. Then variation of x will be delta x, and variance of y is the same as like this. Then slope of regression line will be factor 2 scale multiply 2. This one and this one. So in this case, multiply scaling factor C1 means that slope multiply 1 over C1. Is it okay? Okay. Then lastly, many of the students asked to me, how can I solve theoretical problem number 2, this one. It can be solved by two processes, matrix version and sigma version. First, I will explain about the matrix version. Okay, expectation of SXY. SXY can be right like this. So, expectation of SXY is equal to like this. Then, let's say that this term is equation 1. Then, by using matrix form, equation number 1 can be expressed like this. Then, x transpose is 1 by n, and I minus 1 over n, 1 transpose is equal to n by n matrix, and y is n by 1 matrix. So this term is scalar, 1 by 1. So trace of scalar is equal to scalar. Then by using this one, this term is equal to this term. And trace of AB is equal to trace of BA. Then switching this term and this term. And also, expectation of trace A is equal to trace of expectation A. So, switching these two, then expectation of I minus 1 over N11 transpose, this term is not random variable. So, it is not related with this expectation term. So, it can be cut out here. Then, let's say this term is equation 2. We need to calculate this term. By using some trick. It is covariance of y, x. Covariance of y, x is equal to expectation of y x transpose minus expectation y multiplied expectation x transpose. And it can be calculated like this. This one is this one, this one is this one. Then it is n by 1 vector. It is n by 1 vector of transpose 1 by n. So it is n by n matrix. Then we can calculate this one. This one is covariance of y1, x1. This one is the covariance of y1, xn. Then y1 and xn is independent. So covariance of this term will be 0. So all of the non-diagonal elements of this covariance of y, x will be 0. And covariance of y1, x1 is equal to sigma x1. So covariance of y, x is equal to sigma xy multiply identity matrix in. So equation number two can be rewrite like this. Expectation of y x transpose is equal to covariance of y, x plus expectation y, expectation x transpose. Then expectation of x is equal to ux1 vector and expectation of y is equal to uy1. Then this term can be write like this, and uy and ux is scalar term, so it can be switched. Then just separate. Then this one covariance y, x, this one here, just calculate. Then in here, 1 transpose 1 is equal to n. So n cancelled out. Then this term and this term is same, so it can be cancelled out. Then remaining term is this one, and trace over a b is equal to trace over ba. Then switching these two terms. Then it can be rewrite like this. And covariance of y, x is equal to sigma xy and identity matrix. So this term is sigma xy in 곱하기 1 transpose 1. Trace over this one is n times sigma xy. So covariance of yx is sigma xy in. So trace of this term is n times sigma xy, and this term. Trace of this term is equal to n times sigma xy. So 1 over n cancel out. Then equation number 2 is equal to n minus 1 sigma xy. So expectation of sxy is equal to sigma xy. Is it okay? And let's check the sigma one. Expectation of x bar is equal to this. Then we can separate it. And expectation of x bar is equal to mu x. In the same way, expectation of y bar is equal to mu y. Then let's say that expectation of sxy is equal to like this. Then by using this tree, xi minus mu x plus mu x. By using this tree, we can get this term. Then this one multiply, this one multiply, this one multiply, this one multiply. Then we can get this term. And this red line terms is not related with index I. So it can be found out from this sigma term. So separate the sigma term. Then this equation can be rewritten like this. Then this sigma term, sigma yi is equal to ny. Sigma xi is nx bar. So this sigma term can be represented